This is the appearance of a ripple tank. It's a glass tray. It's a ripple tank and it's a glass tray with a dipper in it. Ripple tank is basically an apparatus used to monitor or demonstrate water waves. So give the heading ripple tank and write under it that ripple tank is used to demonstrate and study water waves. It is especially suitable for water waves. We have a lamp for projection, a water tank, a dipper, a white paper as a screen. This is how a ripple tank can be drawn in a simple way. When you run it, when the dipper runs, it produces waves and the paper below it actually captures the shadow images. Look at the shadow images. This is called a ripple tank and these are the shadow images. So after copying this, you have to copy this diagram. This is a general picture. And ripple tank is an apparatus which produces shadow image. When you tie a rope and you vibrate the rope, a wave pulse is produced in the rope. The wave pulses go and come back. Similarly, water is famous for waves. Look at the screen. Water waves can take different shapes, different positions. Now, give a new heading, waves phenomena.
Done.
Reflection, refraction, dispersion, and diffraction. Diffraction is a new topic. You have to copy this.
Done.
Now give the heading reflection of water waves.
Done.
Now look at this screen, reflection. The waves strike a medium and come back. So when waves strike a plane surface, they come back in the same medium. And this is called reflection. When waves strike a plane surface, they rebound in the same medium. This is called reflection. You must have seen water striking a surface and going back. It's a reflection. Water does it commonly. Water is expert in these things. Water strikes a surface and rebound. When water strikes a surface, and rebounds in the same medium, it is called reflection. Copy this definition for reflection.
Done. Look, the properties. The most common properties of reflection are lambda, wavelength does not change. Wavelength does not change. Frequency does not change when the waves strike the surface, and velocity may change, and also look at the surface, the amplitude. Maybe the wave after reflection become a bit smaller. Maybe after rebound, the wave becomes smaller. This is possible. So these are some important properties of reflection. So we gave the definition. Now you have to copy this screen.
Done.
When waves strike a medium, like a curved medium, when waves strike a curved medium, it always try to shape the medium surface. Look at the blue waves are incident and the red waves are reflected. They are bending. The curved surface is bent inward, so it's also bending like that. When waves strike a surface, they always try to adopt the shape of the surface. When it strikes this surface, that this is a bent surface. So this is a concept which is necessary to understand that waves always take the shape of the surface after reflection. Look at this animation. It's a ripple tank. This is an inclined surface. Look at this shape, inward curve. Wave will adopt the shape of the surface. This is a ripple tank. This is a ripple tank video, and water waves are reflecting from different boundaries. So copy this screen now. You have to copy this.
Time.
Now copy this diagram.
Time.
You have to now give a new heading, refraction in water waves.
Time.
Refraction in water waves. Now look at this screen. This is a ripple tank, and I have made it shallow from one side by putting a piece of block here. And water waves are moving from left to right, and you can see the waves are getting closer. So lambda is decreasing, velocity is decreasing, and frequency no change. So this is called refraction. When water waves move from one medium to another, when water waves, suppose you are standing on the seashore, you can see it live, that water waves are coming from deep water to shallow water. There's a change in density. When there is a change in density, wavelength changes, and this is called refraction. So what is refraction? Refraction is a process when waves move from one medium to another. Now, write down this definition. Speed and direction of the wave change. So when waves move from one medium to another, they bend, they change the speed. Why? Because density changes. So when waves move from one medium to another, there is a change in density, and this feature is called refraction. Copy this screen.
Done.
Now, what about water waves? Again, the same example. If you are standing on seashore and you look at the so-called waves coming up, you will notice that their wavelength is changing. Their wavelength is changing. For example, when water waves move, when water waves move from deep, from deep, from deep to shallow, they show refraction. So when water wave move from deep to shallow, when water waves move from deep to shallow, density changes. Deep water, and if you have a chance of going in water on a seashore, you will see the change in behavior of water. When water waves are reaching the seashore, gradually they lose their wavelength, the wavelength decreases, the waves get closer. You have to copy this.
Done.
Now, this is the experiment which demonstrate the refraction of water waves. And this is an experiment we are doing in a ripple tank. Ripple tank is actually specialized in water and water demonstration, water waves demonstration. And ripple tanks are always there to show waves in water. So we design an experiment. We design an experiment, and this is a ripple tank. And as mentioned, the purpose of this experiment, the purpose of this experiment is to demonstrate the refraction in water waves. Now you have to copy this screen.
Done.
Lambda decreases, velocity decreases, but frequency has no change. Frequency does not change. Frequency does not change in reflection, refraction, or other phenomena. So frequency is very persistent. So when waves are coming, look at the waves are coming, they strike the medium, they enter the shallow region, they get closer. When they move from deep to shallow, they bend towards the boundary and they get closer, wavelength decreases. Look at this screen. So suppose that this is the boundary and water waves are coming like this. These are the water waves. They are coming from this direction. Shallow medium is called denser medium. Shallow medium is a denser medium, while the deep water is the lighter medium. So waves are coming like this, and this is a boundary. Copy this screen.
Done.
When waves move like this, they have to bend. Look, the bending. This is a bending diagram, and you have to practice for it neatly. And there is a normal on the screen. So when it enters the deeper region, when it enters the shallower region, the waves bend like this. You have to draw with me, and this diagram is a bit tricky, but you have to draw like that.
And
So these are the waves arriving at seashore. And now we look it from another angle, that waves are moving from lighter to denser, and they are bending away, bending towards the normal. The waves are moving, and the waves are coming from lighter to denser, deep water to shallow. And this is from the top view. And the waves are bending towards the normal. So you have to now. So right under it, when transverse waves like water waves move from lighter to denser medium, they bend towards the normal. This is a property of all transverse waves when they are traveling from lighter to denser. Here, lighter to denser means, here in our chapter presently, lighter is the case when the lighter is the case. Lighter is the case where water waves are in the deep water. Swimming pool is deep from one side, and lakes are also like that. So deep water is the lighter medium, and shallow water is the denser medium. So you have to copy this screen. This is the video of a ripple tank. Look, observe that the waves are bending on the boundary. The waves are bending on the boundary. And this is the second view from the top, and this is more clear view, the incident water wave and the refracted water wave. And I'm showing the angle also. You have to copy this screen now neatly. Have you copied it?
Yeah.
And now look at this diagram. Look at the diagram, wavelength, lambda 1, lambda 2. Look at the diagram, wavelength is decreasing, speed is decreasing, but frequency, no change. You have to copy this diagram also.
Done.
Now look at three important formulas. Refractive index, n is equal to sin I upon sin r. Refractive index is a measure of bending of a wave. N is equal to V1 upon V2 and n is equal to lambda 1 upon lambda 2. You have to copy this.
Done.
So there are three formulas for refractive index. Now, what is refractive index? Refractive index is a refractive index is a ratio which shows the which shows the degree of bending of a wave during refraction. Refractive index is a ratio which shows the degree of bending of a wave during refraction.
Done.
You have copied the formula. Now look at this formula which I have combined. Lambda 1 upon lambda 2 is equal to V1 upon V2. So you have to copy this. Now look at this question. Waves pass through deep water to shallow water and refraction occurs. What is the speed of the wave in the shallow water? Read the question.
Is it 0.2?
No, see the working. See the working and make the correction. Did you get the working?
Yes.
Okay. Now try, now copy this diagram. I'm just coming. Diagram. The wave is traveling straight. When waves refraction occur, but no bending occur. Why this is the case? The wave is striking at 90 degree. For transverse waves like water, light, EM waves, lighter to denser bend towards the normal and denser to lighter bends away from the normal. You have to copy this.
And
Now, solve this MCQ. The diagram shows the refraction of water wave as they cross a boundary in a ripple tank. What causes this refraction?
a change in the speed to the change in the depth.
Sorry?
A change
Yes.
in speed due to, yes.
Change in depth. The waves move from deep to shallow. Now, look at this question. This is lambda 1, this is lambda 2, this is V1, and we need to find V2. I have marked the data, and the formula says V1 upon V2 is equal to lambda 1 upon lambda 2. You have to copy, you have to just put the values quickly and solve it.
I'm getting
Okay, what are you getting?
24.
6. What are you getting? Please tell me. The answer is 6. If you put the values, look the working.
Do we not divide first 3.3 divided by 1.5?
3 divided by 1.5. What? Can you repeat?
Do we not divide them first?
You can divide it. 3 divided by 1.5 will be how much?
It's 2.
How much?
2.
2. How it's 2? Can you check it again? 3 upon 1.5. It's 2. Right, it's 2. Then cross multiply. You're right. 2 is there. Then cross multiply. V2 goes there. 2 comes down. It will be 12 upon 2. You might be making a mistake in cross multiplication. Check your cross multiplication. Now, if you cross multiply, it will come like this.
Yes, it's 6.
So we stop here and we will inshallah continue this in our next class.